Good morning, everyone. Today will be a last session, and but the Center of Academic Study will actually have arranged some other training session in the near future, right? So today we'll do a structural equation modeling, right? We as like last section we'll break into one and two, and here this structural equation modeling I will use smart PLS, right? This regression technique is very useful for the survey type. I mean the primary data survey type, right? So not like as mentioned before, we have secondary data and primary data, right? Secondary data is when you download all the data, right? Especially from World Bank, IMF, World Trade, or whatever, or Batan Statistics, Malaysia, and we just run. If primary data, that means we need to collect it ourselves. We are the first hand, right? So usually we collect through survey. Nowadays, of course, we can use online, we can use physical survey, but of course, we have to take into consideration the ethical clearance or ethical thing, then the feasibility, the practicability. If you use online survey, you just share the online survey, most likely you'll get all the same. Like let's say you want to target university, so you send all, or university lecturer, you send all to all the university, you cannot get a respondent, or you send to your friend or share in your Facebook or social media, you'll get back the respondent is all your friend. I mean, they may have a respondent bias. So that one is you have to take care, right? But here, this structured equation modeling, last time this type of survey primary data usually use SPSS, right? That one is the most famous for so long, right? For to run an equation. So when you run SPSS, you give you an equation just like when you use the Stata to run the secondary data. You have one y equals to x1, x2, x3, right? But the question is you may have more than one equation, right? X1, X2 may have different relationships. So therefore, come this new thing called structured equation modeling. And for UTA, it's very useful because as far as I know, for international business student, right? Their research method, I think Dr. Law Mei Ping got teach also structured equation modeling, and then they do survey. Mostly international business student, their thesis is do survey. So in this case, it's good for the supervisor to guide them also on this new method structure. It's not new actually, structure equation modeling, right? For building and property, when I teach research method at time, I also got teach them structure equation modeling. So maybe in near future or even currently or in new batch or FYP, our staff here will notice that many of our supervisors will start to use this method for their thesis, right? If you are doing for your master or PhD, right? You do a survey or you can also use this one. And sometimes you also notice that getting grant, if you propose a primary data research, it's easier to get a grant because it's something new. You need to collect the data, and the data and the result that you come out is actually valuable compared to you take a secondary data, people already collected, you just go and run some other equation only. Okay. Now, structured equation modeling one, this model will focus on how to perform the equation modeling using smart PLS software. This smart PLS software, you can either buy the licensed one, the whole package, which is very expensive. Use your institution, either UTA or other institution. I think most of them got buy. They have a computer lab, right? You have to go there, you save the data and go there and run. Or you buy the package in monthly term or in weekly term. They got this so-called short-term package, right? Their license for monthly, and of course you got other ways to do it to find it right? Just smart PLS, then you can find anyway, right? Shopee, I think also got, I'm not sure how. It cover initial step will generate result. So because of time constraint, this this structured equation modeling is not easy, right? And two hours won't cover everything. So we'll cover the basic one. At least you know how to use it. Then later on, from the first step, you can go to second step, third step, fourth step, right? So here, this can see my mouse. I use the laser pointer. You see the logo like that, right? There's another logo, square one, right? So we'll introduce to structured equation modeling, and then we'll be more practical how to open the smart PLS like last time, how you open the Stata, how you prepare the data set, right? You tell the starter, this one is a final data. What? So it's same thing you do to a partially square smart PLS. Then you know how you connect the latent variable. Here, for structured equation modeling, the term might be slightly different. Okay? In secondary data, we call dependent variable or independent variable, but here we call latent variable, right? And then indicator. Okay? So then you get output and diagram for the first part. Okay? Now, so what's so good now? Structured equation modeling is a combination of path modeling or multiple regression and factor. If you use, of course, this one is the most basic one, right? If you use SPSS, you can only give you one equation, like last section, right? Y equals to x1 plus x2 plus x3, then full stop, right? Here can be more complex. Can be y equal to x1 plus x2 plus x4, and then again, y also be affected by Z1, Z2, Z3, and then Z1 will also affect the X3, and X3 then go to X4. So, but here we don't do so complex first. We do a simple first. So we assume Y affected by A and B only. Okay. So a combination of either one or multiple regression can be done. Structural equation modeling has the ability to test multiple regression model. SPSS only tests one multiple regression model, right? Or equation simultaneously, different from testing one at a time using SPSS. Okay. So in this case, you notice that your smart PLS or your structural equation modeling will be something like that. You have three latent variable. If based on the last session concept, this one will be your dependent variable. This one will be your variable of interest, right? Your focus on this one, right? Your focus. Then Y will be affected by A and B. Okay. So the most simple model, we have this Y, right? Factor affected by the A and B. Okay. But the thing different is this A is actually construct using question A1, A2, and A3. Of course, you can have more. This vector B, how do you get the vector B? You get it from, you construct it from the answer, your survey answer for B1, B2, B3. Therefore, you notice in one of the session when we do collecting data, the questionnaire itself, I usually practice that if let's say this question is for A, so I put A1, A2, A3. This question is for B, I put B1, B2, B3, B4, B5. This question is for C, I put C1, C2, C3, C4, C5, right? But some people still prefer to use 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 21, 22, 23, 24, 25, right? So, but if you want to, let's say 1 to 50 question, 1 to 50, then you do not know whether 1 to 3 is for A, then 4 to 6 is for B, then 7 to 21, 7 to 15 is for C. So it will be a bit troublesome. So I would suggest that you structure or label your question based on the factor, right? Later you'll see. So Y1, Y2, Y3 for factor Y. Of course, you can have more later, right? So A, B, and Y we call latent variable. Then this A1, A2, A3, and so as B1, B2, B3, and Y1, Y3 is called proxy, or sometimes they call indicator, right? Or sometimes they call observed variable. So A1, A2, A3 is a proxy or indicator for A. B1, B2, B3 is a proxy or indicator for B. Y1, Y2, Y3 is a proxy or indicator for Y. Okay. So the path modeling will be C A to Y. So very simple, right? Of course, you can have more difficult one, A to B, then to Y, or A to B and to C and then to Y, right? You can have more things. Then another path will be B to Y. Okay, so you'll get your beta or your path coefficient later on. Okay, so what's so good? So the concept of structured equation modeling is something like that, right? You compare back to your primary data, it's about the same concept. So in this case, Y, even though we call latent variable, is your dependent variable. This one is your X1, this one is your X2. So you have the Y, but here one by one A, the number you get from this relationship is your beta. This one, you have another beta, just like last time you do Y equal to X1, X2, X3, X1 got beta 1, X2 got beta 2, X3 got beta 3. So it's still the same. But here you can do it more complex, but you go for more complex first. Okay. Second, Why like that? Why still got one more people? Wait ah. Why still got one more? We have go already. Ah, okay. Can see back the slide. Okay. Here, this one block my view. Okay. Open and prepare data set. Remember, you book later, which I show you later. You have your Excel file, right? When you do the survey, you either key in because you use a physical survey, you take a print on the paper and then you ask people or let people speak up, or you use Google Form. If you use Google Form, everything will be put nice, right? Then your result will be compiled in an Excel format. But partially smart PLS can only read CSV, delimited. They got two type of CSV, right? Two CSV, delimited. If you are Utah staff, then you want to key into the ICGPA, also you have to convert to CSV, delimited. So same thing, right? You want to key into the ICGPA, you cannot upload the Excel file, right? You do the thing in Excel file, then you convert into CSV, delimited. Same thing you do for this one. Your raw data you put in Excel file, nice. Then you convert into, you save as CSV, delimited, and then only SATA can read this format. Okay. Then you open data set. Later we'll show you one by one. You click the file, then you create new project, give it a name. Later I'll show. Then this PSS training, you click, then you import data. Double click the import data. You'll find something icon like that. Right? Here you see, already give you instruction, double click to import data. So you click, double click, then you import the data. So you import back your Excel file, the data file. Right? Then click the path model PLS training or the new path model icon. So you either click this one, right? Or this one. Right? Both also give you the same thing, right? Okay, one by one. This one, okay. I think I better share the screen. Wait, you have your data set. This one I already saved as CSV. You remember this same data set I used for example, right? You have coding all this thing, right? So you open your file, you save as delimited. This one is already saved in delimited. Usually you have Excel workbook, right? So here got two CSV, not this one, this one. Okay, exactly like what we done do in a, you convert from an Excel file, key in the marks for student exam, then convert to CSV, then only we upload to the ICGPA system. So exactly like that. So you save in this one. This file I already saved in CSV limited, right? So exactly you see exactly the same thing, just the format different only. Okay, then you click your smart PLS, right? My desktop there already got smart PLS. You click, you get this screen. Okay, this one is a past project I have done now, right? It's okay. You get this screen. So what do we do? See the slide. Convert already done. Open data set. Click the file or create new project. So click the file or create new project and give it a name. So you either click the file, create new project. Okay, here. Yeah. Wait, I do it again. See, file, create new project. All right. Give it a name. Right. I already give the PLS training, but now I keep PLS 2 lah. Okay, so that it won't clash with I trial run one before. Okay, any name you like, right? Maybe your project is consumer satisfaction or whatever project title you want, right? Then you keep a title ABC, right? Right? Then you click OK. You see, you come out like that. Can see here. Yes, training 2. Double click to import data. Okay, so next, you double click to import data. You click this one, right? 1, 2. Then the data set is here. Already CSV only one file. So you click your data set, right? If you Excel file cannot, only one choice, right? No other choice. You put Excel file only, you won't see anything, right? So open, just okay lah. Then we have all this data imported nicely. Okay, you can click here for correlation, raw file, right? All these things, your correlation table, what indicator, all this nice already. So we are on this tab, right? We are on here, right? Then click the path model, PS training icon. So this one, or new path model. You can see when I switch the slide. So can see this one icon, right? So usually I'll click this one, double click, you come up with a blank thing. This way we are going to draw uh, something like that. Okay, you can do it very complicatedly, or based on your theory, or based on your model, or based on your objective, based on what you want, right? As I said earlier, here we do the most basic first. Okay, so now you get a blank one, right? You get a blank one. So we start to draw, okay? Draw the Latin variable, right? So Latin variable, you find this symbol, not this Latin variable. Okay? Click the Latin variable icon and draw the circle. So this symbol, see carefully, this symbol, okay? Now I switch back, where? This one. Can see? Screenshot the symbol here, right? You click this one, then you can see the plus sign. You just click, you come out nicely. Just click only, right? You see, still you can click as many as you like. Just now we have our model is 3 only, right? Then we click 1, 2, 3. Okay. Then after finish, you put escape lah. Put escape, right? Or you put select, right? After finish, you put escape, put select. So you got 3. Okay. So exactly like this one. Okay. This one. You see, now it's red color. Red color means something wrong, right? But it's okay because we haven't done anything. Just 3 circle only, right? Choose and click the select pointer icon to select or move. So you either click your escape button or you click the select, then you everything done. You see, I show you. It's like that, right? So you click the select, then no more. Okay. Or you just press your escape button. Right hand click on the circle and rename. Okay. So just now we have factor A, factor B, and factor Y, right? So here, you right hand click here. Got many things, right? Okay, again, you switch here, right hand click. Wait, I give you see the scene. Error. The Latin variable is not connected to other Latin variable. That's why this error, red color means error. Why? Because it's not connected. Any connection? No. The Latin variable has no indicator. See, okay, first, the Latin variable had not connected to other Latin variable. Mean what? We haven't connect this line yet. This line. This line. Wait, this line, right? We haven't connect these 2 lines yet, right? Then the second one mean what? This Latin variable has no indicator. A don't have A1, A2, A3. B don't have B1, B2, B3. Y don't have Y1, Y2, Y3. This is an indicator. Nothing, right? So nothing, that means red color. Okay. Then C got anything? The variable is part of an incoherent graph. That means just like 3 dot, nothing. Right? Here. So still error. We click right hand click. See rename. Okay, you just rename. So you can put factor A, automatically come out. Of course, in your research, you got your own name, like e-wallet, perception of e-wallet, and then number of e-wallet usage, or something. You have your own actual name, but here we just put factor A. And click OK. Do the same thing. Right hand click, rename, factor E. And then right hand click, rename, factor Y. Okay. So the slide I give you is step by step. So you click on this one. You notice you have this one. Now you rename already factor A, factor B, and factor Y. Okay. But still red color. No, the circle are red because not yet connected, and you also don't have the indicator. Okay. So it's okay. Right. So also good. Click the circle out. Click this one. This one click, then you come out the circle. Right. Next, assign indicator. This is the indicator. So you assign the indicator. Okay. So here, okay, can you see this slide? This slide, A1, AB, A1, A2, A3, A4, A5, right? B1, B2, B3, B5. That's why, as mentioned just now, if this first 6 question is for factor A, I'll prefer to rename it at A1, A2, A3, A4, A5. If the 7, 8, 9, and to 11 question is for B, I'll rename it at B1, B2, B3, B4, rather than 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Then in this case, it will be a bit confusing. Okay, so you do click here, you shift until 5. So A1, A2, A3, A4, A5 is for 5, right? You click, don't let go your mouse, go to the factor A, then let go. You got A1, A2, A3, A4, A5, correct? So you see, you click all the necessary indicator, right? Indicator, then you drag over to the A, then you release. Later you try B1, B2, B3, B4, then you click, don't still press, hold your mouse and then release, right? You choose for the indicator, drag them to the factor A, circle and let go. So we repeat with all the latent variable. Okay, wait, we repeat first, then factor B, B1, shift, right? If you don't want, you can also use control, right? You can skip, you can use control, right? B1 to B5, click, left hand click, now just click left hand click and then hold your mouse, click, hold, drag here, and then let go. Okay, same thing. Okay, let's say the factor Y we put F lah. So F1, F2, F3, F4. You can also one by one control. You press control and then you click. Okay, then click the left hand of your mouse. Left hand click, hold like that. Okay, so good. You can also drag any way you like. Up to you. And you see, right hand click. You notice, you see this, all this or not? You can align up, left, down, or right. So it's your choice. Okay. If you still not satisfied, or sometimes when you come out with the number is too narrow here, you want to have some space, you can do it manually. Your choice. You want to design how nice or what pattern you want to do like that, or A, B, C, D, also up to you. Okay, but usually you try to make it not so congested, but it's okay. After you run, then only you rearrange also can. Okay. So now we put in the indicator, but it's still red color, right? Can anyone tell me why it's still red color? Red color means got error. You see here now, the latent variable is not connected to each other. The variable is part of an incoherent. Just now, we have one more, right? The latent variable do not have indicator, but now we have indicator already. So what is missing? Not connected to each other. Okay? So we still need to connect it to each other. Okay? We don't have these two lines yet. Okay? We only have here. So this model is without connection. So still red color. The arrow pointing. Okay. One more thing. You notice that in this case, the arrow is pointing out. Okay, this one, you think you can set to here. This one you can set to here. The red color circle and the yellow color square, the arrow is pointing out from the red color circle to the yellow color square. This means reflective model, right? Reflective model for me is a little bit easier, right? But whether you choose easier or difficult is not because you think it's easier, so you choose easier, because based on your theory, based on your needs, right? So, but we can only cover reflective model. So pointing out reflective model, pointing in mean what's the name already? It's another different reflective and constructive model. It's different type of model, right? Something like that. It's just like I see you wear expensive clothes, take expensive handbag, eat expensive food at the expensive restaurant. So is this all these expensive restaurant, expensive meal, expensive handbag, expensive clothes, expensive shoe, right? And a very nice diamond ring. Is this a reflective that you are rich? Or is this because that you are rich, then only you wear nice diamond ring, wear nice clothes, expensive handbag, and dining at expensive restaurant? So either reflective or another one I have forgotten, constructive, because I usually rarely use constructive. It depends on your theory, but here we do reflective first. We do reflective first because you have different model will give you different set of running. Okay, so we assume all are reflective. Okay, so after this, we need to connect. Okay. So far so good. Okay. We click the Latin variable. We rename, right? Then we assign the indicator. Okay. If this one you still have like that, right? You don't want, you click select or click escape. If you don't want, you just delete. Okay. Then now we have all these things here. Now we connect. You see here, connect. Click here. So A to Y, B to Y become blue already. Can see? So everything nice become blue. So if you don't want the arrow there, you click select or you press your keyboard escape. Okay? You either click select or click keyboard. So we have a model like this. Okay? From the red color one, right? Then you have here you click the connect icon, connect factor A to Y, and then connect factor B to Y. When all latent variables are connected, the circle will turn to blue color. Okay, so also good. Okay, or you want to repeat one more time? So far so good. Can? Never mind. We can delete everything. Okay, we delete everything. We try one more time. Later you will understand, right? You click this one, latent variable, right? You have three, right? So 1, 2, 3. Still arrow like that, right? So either you press the escape in your keyboard or you click select. Then you arrange lebih kurang lah, agak-agak, right? Lebih kurang. Then you rename. This one, right hand click. You see here, you got 3 things you haven't done yet. Actually, 2 things only. After you done everything, you will have graph coherent. Yeah, no indicator, not connected. So right hand click, rename. Vector Y, rename vector A. Okay. Right hand click, rename vector B. Click OK. Still red color. So we assume F1, F2, F3, F4 is assigned for vector Y. So you drag here, click. Then A1 to A5 is assigned to vector A. You left hand click, hold your mouse, drag to here and let go. Just like you want to copy and paste your move your file from one folder to another folder, exactly the same. Or you want to upload something, or you want to do attachment to your email, you click the file and then drag to there and then you let go. So B1 to B5, click here, let go. Okay. Then you can click the right hand click. You can change this one. Let's say we want to put it on the right hand side. Vector A, you want to go for the top. Align indicator top. So all these are indicator. A1 to A5, you want to align to the top. Of course, you can manually adjust it. This one you want to align to the bottom. Okay. Still red color because latent variable is not connected to other latent variables. So no connection. Then you see here connect, right? So you click the connect, you see your mouse also different already. From here, click one time, drag to here, click second time, connect. From B, click one time, drag to here, connect. So all connect, yeah, blue color already. Then you click the escape key in your keyboard, then it's very nice already. Okay. Next. Like that, right? Run the PLS regression. Okay. Here you actually got 2 PLS regression. Okay. Here You see this one, file, edit, view, team, calculate. Okay, you click the calculate. You got actually two. PLS, wait first. Calculate, you actually got two, right? Actually, you need to run both because each one give you different result. You need both to complete your whole result set. Okay. Firstly, you run PLS algorithm first. So calculate PLS algorithm, you click. Okay. Here minimum iteration. This one is a because smart PLS they use bootstrapping. So every time you run, it's better for you to save everything because if you rerun again using the same data, everything is the same, your output or your result might be slightly different. Maybe your first result is 1.2345. Second one will be 1.2348, right? Something like that, right? Or 1.2344, right? It may not be exactly the same because bootstrapping means they use sampling, random sampling that they'll be do themselves, right? But of course, it won't be the first one you run is 1.2345. The second one is 9.8754. So you only different that much. Then minimum number we put here usually is put 200, but I would like to put 500 lah. 500 will be you put two. Sometimes the journal or your institution requirement will require you to put higher number like 1,000, 2,000, but at least you put 200 lah, the minimum 200. But here since give 200, it's okay lah, 300, right? And when I do the trial run before I do a training, this one I put 500. Then I can put 500 now, okay? Then you click. Your computer is not that fast. You put 500, 1,000, you take some time. Then after that, right, you click start calculation. You can see the bottom right. Click start calculation. Let it run. Oh, this one quite fast, okay? So you get like that, okay? This already indicate the half coefficient, right? That means, okay, 0.184, 0.5, later we see this one, but here you click, here you see 0.184, right? So this one is your beta. Then factor A and Y, the relationship is 0.184. This one is 0.5546, okay? So you get something like that, okay? So what I ask you there is that you right hand click this one, right hand click the picture here, then you export as an image to file, you save it. Okay, export image to file, you save it. So this one last time I saved already. You get like that. You get this one. Okay, this one. See the picture is slightly different because maybe later on you see, or maybe this one you see, oh, too congested here. It's very hard to see. So you can drag and drag and drag and drag. So you make it nicer. It's up to you. Okay, like that you can see more clear. Okay, clearer. Right? Maybe you see, oh, cannot see so difficult to see. Then you can drag out a bit. You can manually adjust that one, right? So it's okay. Okay, something like that. Okay, you save this one, export as an image file. Right, this one already done now. Right, you give your name, whatever ABC. Right, then you click save. Okay, then you go back to here. You see got two. This one is the graph, the diagram. This one is here. Okay, you see on top here also different. On top here. See, and this one on top here also different. You have to click this one, and then of course you can see one by one here lah. But as I told you, it's better to save everything first. So export to Excel. And see here, export to Excel. You click, just start export. Okay, again this one is a diagram. You see on top here also different. Then you click here. This one is just the data diagram. This one is the number, right? You can click all this one. You give you the number, but no need. Just export to the Excel. So here export to Excel. You click export to Excel. Everything just leave it like that lah, because it's already default, right? Then start export. So you put lah ABC. Actually, I already export ABC 1, 2, 3, right? Or ABC1. Okay? Or I'll prefer to do like that. You put ABC and then underscore, because you run this one, right, using PLS algorithm, right? PLS algorithm, okay? Or maybe you need to rerun and you try certain version, or you have many model, you can put model 1 or version 1, right? Or just 01, right? Maybe later you have to retry again, you put 02, right? Or you have to retry a new model or add in one more wherever you put 03. Up to you, up to your labeling. But usually I'll make sure that, oh, this Excel file is actually get from our algorithm, not from bootstrapping. Later we put bootstrapping, okay? So you save. Okay? Later we'll see back the file. The file will come out. Can you see the Excel file? Come on like that. Okay? So you can click and click anything. Okay? You can click. Later on we come back to this file. Okay? So now we just leave it like that. Okay? We just leave it like that. Okay? So far so good. So good. So we are until here. See? Right hand click the diagram, choose export as image file. Right? Right hand click the diagram, choose export to as image file, and then you save. Okay? This one step by one step. Then here, this one I use bootstrapping. Later we run to bootstrapping again. Right? Here, right? In this case, it will be PLS algorithm, right? Then export to Excel. See, you need to run two. You run one first. Then click here, export to Excel. You can see. Then you come up with the Excel file like that, right? Find this icon at the top row, right? Click it and then start export, and you get the result here. Okay. So also good. We need to run two, right? Then okay. After that, we go back to here. Go back to this diagram. Go to calculate again. Okay, calculate again. This time, just now we run PLS algorithm, right? Now we run bootstrapping. Click this one. Just now we run 500. Now we run also 500. Okay. Then here you notice significant level. So the p-value or they give p-value, but whether significant or not, you based on 0.05%. Okay. First you can set up, but usually common standard we use 5%. And then start calculating. Okay. You try again with close. Again, same thing. Click calculate here. Can see the point here, calculate. Just now we run the PS algorithm. Now we click bootstrapping. Right? Put back the similar subsample like just now. Just now 500. So start calculating. Right? You see the difference or not? Now you got the p-value. Just now you don't have the p-value. Right? Okay. Then you notice that now you see just now you don't have the p-value. Now you have the p-value. The number 0.184, 0.184, 0.5546, 0.546. Sometimes maybe different a bit like 0.547, right? 546, right? But here you just full stop, no more other thing. Here you got a t statistic and you got a p-value. Okay, p-value 0.042 means significant, not significant at 1%, but significant at 5%. 0.0000 means significant at 1%. Okay, so you see, same thing. Then you click the diagram. You notice it's the same, right? But here, look at this side. The left-hand side bottom, you can choose, right? You can choose inner model, outer model. Usually I'll choose that outer loading with p-value. Now, then you see you got inside the p-value also. Okay, I mean you can straight away see if you just use the t-value, you do not know whether this A5 significant or not, this A4 significant or not, this A1 significant or not. Then you choose unless you see the data, see the result, you choose the p-value. So you see all these numbers are like overlap each other. Therefore, you can move it, move it, move it. You cannot move it. So you can move it to a nicer setting, right? You can move it. Still overlap. Like this, sikit-sikit okay lah. So you can see all the number here. Here still cannot see, then you move it, and move it. So very nice. Here also all overlap each other. You move it, move it. Okay, so can see here also overlap a bit. Then you see everything can be seen. So from here you see all the indicator are significant, right? All the indicators are significant. All the indicators are significant. If let's say one indicator, let's say this one is not significant, so it's up to your choice, though. If let's say this one is not significant, it's 0.5678, right? Then up to you, though, whether you want to retain this B1 or you delete it and rerun again, right? Without this B1. That means you just assume the indicator for vector B is just B2, B3, B4, and B5, right? That's why also when doing the survey, construct the survey question, the indicator try to be more, maybe 5, right? If you use only 3 questions, let's say B1, B2, and B3 for indicator vector B, first it may not be representable for B. That means they may have other question that you fail to ask, or suddenly question B2 and B3 not significant, you cannot delete. And then if you delete, you only left 1. So usually I advise that for each letter variable, you can have maybe at least got 5 question or 5 indicator. Of course, each indicator actually is where you get the answer from B5 is a survey question. Okay, you get from a survey question, all this B1, B2, B3, B4, B5, A1, A2, A3, A4, A5, Y, F1, F2, F3, all these are from survey question. Okay, so you make your diagram nice already. Again, right hand click, export as image to file, right? So you want to put maybe A, B, C diagram. I would like to label the diagram and the Excel format so that when I see the name, I already know what's inside. ABC diagram. This one is bootstrapping. Maybe this one is the first version or 01, right? You should put 01 because I may need to run more than 10 times. So 01 and then you save. And you got the diagram already. Automatically come out for you also. Okay, can see? And this diagram you can cut and paste in as your result. Okay. Okay. Then go back to see algorithm still here, bootstrapping still here, repeat the same thing, export to Excel, right? So all this you repeat 2 times. One is for bootstrapping, one is for PFS algorithm, right? So you click this one, export to Excel. Can see or not? Next time you can refer back to the slide and then one by one because you may not remember every step, so you can see that from the slide. So export this one, click. Then here, start export. Right? As I mentioned, this one you want to say that ABC, right? Underscore. The last time we put PIS algorithm, right? Right? Now you put bootstrapping. Okay. As long as the file name, you see the file name, you know, oh, this one actually is a result for bootstrapping the first time, or maybe you have run another time 02, or you try another new model 303. So you see and you click save, you see the file name, you know what is inside, and easy for you to manage next time. And you come out the file name, no man. Come out also. Okay. At a glance, you notice that it's exactly the same, right? You see that it's like exactly the same one, right? Not much different one, but there are some difference lah. There are some different. You can see also here there are some different, right? See from here also, one from the PLS algorithm and one from the bootstrapping. There are some different. We'll come back to this one later. Okay. I think mentioned to you earlier. This book is actually I'm using this book, right? You got give step by step. Now I'm not sure what edition already lah, right? Then I also try to Google and see there's many other books that actually quite helpful, also step by step, right? Written by university lecturer also, so you can buy anyway, or you can go to your university library and then you will borrow. So model 10B, structural equation modeling tool, as I mentioned, long time ago we use SPSS, right? Not to say SPSS, every model, every software got their pro and con, got the advantage or disadvantage. But nowadays, more and more people will use this structural equation modeling. And among this structural equation modeling, two of the popular software is AMOS, which is part of SPSS, and Smart PLS. Smart PLS is quite user friendly, as I showed you just now. It's a click, 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 and then you connect, and then you click calculate, and then you run. But the difficult part is how do you get the number from the Excel file that you have saved just now? So the second part here is actually on how you extract the data or the result from the Excel file you saved just now. The click, click, click is very easy, right? And so still, as if you are in Utah or maybe in Yata, UMT also got many join, right? When your student start to do survey questionnaire, or when you want, or maybe you want to apply for research grant, as I mentioned, research grant, I noticed that you use survey or primary data collection, you can justify the budget that you put in. You cannot justify that I want 50,000 to download secondary data. Download secondary data is usually free of charge, and you cannot pay yourself salary for downloading the data, right? So you ask our RA to download the data also a bit weird because it's very easy. Just click 1 hour or half hour, you can finish download the data. So you cannot justify the budget. So if you can justify the budget, for what they give you a grant, right? Mostly they give you a grant. Of course, you have to have a relevant and significant topic lah. So if you have do primary data, you need do survey, right? When you do survey, then you can try use the structured equation modeling. And student in UCA also, I noticed that even degree student also, they tend to move from SPSS to Smart PLS because what I see is two research method class. One is teach by me, one is teach by Dr. Lo, right? We also got teach them structured equation modeling. So it's good for all the staff to know as well, right? So now, first part, if you learn how to click, 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 connect the diagram, and then download the Excel file. So second part is more on how to present the result or a reflective model, right? And then cover the checking and various creation or interpreting the instrument. Most in general mean how do we get the result from the Excel file that we save? Okay, so we have all these criteria: internal consistency, convergent validity, discriminant validity, ordinality, quality, R-square only, structural model. So you follow step by step. At least you can finish your research project, or you finish your thesis, or you finish article for journal publication. Okay, so step by step, or you can see this book, right? I also use this book. They got give you step by step, or you download a journal article, right, that use Smart PLS or structured equation modeling, and see how they do it, how they arrange one by one. Okay, first, internal consistency first. Okay, internal consistency. I didn't put slideshow lah because I want to ship the thing here and there, right? You can like this still okay, still consider okay. You have three measurement or three indicator, right? Usually SPSS or last time we only use convex alpha, right? But here you can provide you two other alternatives. So you get row A and then composite reliability. So all this measurement, where do you get from? You get from Excel file you save by calculate using PLS algorithm. Remember or not? Okay, I ship the file. So the one you calculate PLS algorithm, okay, is file. Okay, then construct reliability and validity. This one. So you get from construct reliability and validity. So internal consistency, you use this one. Okay, then you click here. You see the Excel file? You see the construct reliability analysis, you click here, I just put a tick, right? So you open back this training slide, you follow step by step here, you can find, okay? You click here, there's algorithm file, construct reliability and validity, show, click, you get like that, down here lah, down here, can see or not? You scroll down, you get like that, okay? Then you copy the whole table. Not really copy the whole table and cut and paste like that lah. Of course, you have to put it in a proper table format, and this table format also up to the journal requirement, right? Some they cannot have horizontal line, vertical line. Then it also depends if you are postgraduate student, it also depend on the university requirement. But the info you can get from here. Except this one later on. So you see, batch alpha, row A, composite reliability. Okay. See, 1, 2, 3. So that is your result for internal consistency. For internal consistency, you have to present this result. And as a rule of thumb, it should be between 0.7 to 0.9. Less than 0.7, that means not so good, but over 0.9, that means they are really not that different from each other, is also not so good. So the best is 0.7 to 0.9, right? Or at least more than 0.7. So you can see from here, all of them are between 0.7 to 0.9. This one is slightly higher lah. It's okay lah, because this one is for testing, right? It's okay. You do a proper model. If you get 0.9, 0.95, 0.97, 0.11, 0.12, 0.03, then they mean your initial model here, something wrong somewhere. Maybe not just A and B only, maybe C, D, E, that many other factor, or maybe your contract, everything. So your whole model, then people will question you. You based on what theory? Why your result come out so weird, right? So if you based on theory or you have a logical explanation, then you won't expect it. Everything here got problem lah. 1 or 2 is okay lah. Okay. So first part, internal consistency. You have to present just now all the 3. Then you also have to present the convergent validity. So internal consistency, convergent validity, you use AVE. Can see or not here? Exactly the same thing, same construct, reliability, and validity also. Just now we use the first 3, right? Then the AVE is the last one, right? Same table they give you. So you have to present right here, AVE. You see? Same like this now. This now is 1, 2, 3 only. Batch alpha, row A, composite reliability. Row A is usually in between of these two lah. Right? You get the number is between these two. Then for convergent validity is AVE. This AVE, of course, if you read the book or you want you to do it in a more detailed manner, AVE must be at least 0.5, right? If less than 0.5, then you have to have some other consideration, right? But we just take a rule of thumb. AVE must be at least 0.5. So here you see AVE 0.66, 0.7, 0.791, then it is okay lah. More than 0.5. Okay, so consider pass. Okay? And as I mentioned, this model is just very simple. So maybe some of the number here do not meet the requirement. Okay? Next, you see one by one. Discriminant validity. Okay. So discriminant validity, you have this one of it, right? Fornell-Lacker criterion. Where do you get this one from? Also, calculate using PLS. You get the Excel file from calculate using PLS, which is here. You see here, got 3. Complete chart is usually we don't care. Complete navigation. You go back to navigation. Discriminant validity. A different color lah. Maybe this one green also very nice. So this one, correct? Again, you click, you give you discriminant validity. Usually come out the below one. You scroll back. So one of the discriminant discriminant validity is Fornell-Lacker criterion. Okay, then this is the result that you need. Okay, you see. So how to interpret this one? The number on the diagonal should be higher than the value on the off diagonal. So the diagonal is this one. Okay, I make it bigger, right? 0.817 should be higher than 0.7, 0.5. 0.859 should be higher than 0.68, right? And 0.72, 728. 0.84 should be higher than 0.68, which is 0.58. If this number, let's say this number is 0.123, that means something wrong somewhere, right? So this diagonal should be higher than the off diagonal. Okay, so there's the interpretation. So the number of diagonal should be higher than, right? So that's simple, right? This one is just like prerequisite. So you have to do all these diagnostics prerequisite tests first before you go to interpret the path modeling. Okay, so also good. We have internal consistency, convergent validity, discriminant validity. Oh, discriminant validity still got. Okay, so discriminant validity, one of it is Fornell-Lacker criterion. But just now when we click this one, you notice or not, you still got other thing, right? Where's this one already? Another one will be still discriminant validity cross-loading, right? You notice or not? When you click this one, discriminant validity, not only Fornell-Lacker criterion, you also get cross-loading here, right? You can always come back to this navigation, right? Click here, okay? It's the same, right? It's the same. Just like you show it here. If you don't want to click navigation, of course, you can scroll down and find yourself lah. Oh, scroll down one by one. Okay, where? Unless you're very used to it. Otherwise, just click this one. It'll give you, right? Discriminant validity, right? These two. Okay. Now, cross-loading. How to interpret the cross-loading? Also, you get from the Excel file that you save by calculate using the PLS algorithm. It's just now we do two, right? One is using PLS algorithm. One is using bootstrapping. So mostly you use from here. Okay. And the loading of A1 to A5 for factor A should be more than other factor. Okay. You see, I make it bigger. This is the loading A1, A2, A3, A4, A5 is a question in your survey. Your survey question 1, 2, A1, A2, A3, A5. This A1, A2, A5, the question mainly to measure which factor? Measure factor A, right? Your question A1, your question A2, question A3, question A4, question A5 is to measure factor A, right? Not purposely to measure factor B, right? Not purposely to measure factor Y, right? So in this case, your cross-loading for factor A should be higher than B and Y, right? If your cross-loading for A1, A to A5 for factor B is higher than A, that means you thought that question A1 to A5 or anyone, let's say A2, right? You thought that this question A2 is for you to measure factor A, but for incidentally or whatever or technically problem, this question A2 seems to be more suitable to measure factor B because this cross-loading is higher. So in this case, got something wrong somewhere, right? Okay. So therefore, one of the discriminant validity is to check cross-loading, and you can get the result from the Excel file that you download using the calculate using PLS algorithm. Then when you check, how do you interpret? A1 to A5, supposedly to measure for factor A, so the loading is higher. Then you see B1 to B5 are supposedly to measure factor B, right? So you can expect that this factor B 0.85841 is higher than this both two, right? All the factor B here, right, is higher than A and Y. If let's say B3, factor A highest, that means B3 you are intended to as a measure or proxy for factor B, but Malatau suddenly this B3 seem to be reflect factor A or measure factor A better. So should B3 become A5, A6? Right? So should be like that. So you see, if factor F, F1, F2, F3, F4, your intention is to measure factor Y. So the factor Y should be higher than the number for B and A. Okay, so in this case, you meet the criteria, then it's okay. Okay, so far, so good. Okay, why I cannot exceed? Okay, okay. So factor loading. Another discriminant validity is this called HTMT, heterotrait monotrait ratio, right? Also can get from the Excel file that you download when you do the calculate using PLS algorithm, right? You remember or not? You calculate PLS algorithm, right? You cannot use this one now. When you want to calculate, you see, you cannot press anything, right? Because this one is already a result, already calculated, right? Already calculated for you. So you want to calculate again, you have to go back to the diagram, right? Diagram, and then calculate. When I first use this one, it's very confusing. Like this now here. Oh, calculate. But how come cannot press anything? So start to get panic, right? Try and try and try and try. Then after that, oh, get already. Download Excel file. After download, then how come this item I very clearly remember got seen before the Excel file, but suddenly I check, no, right? Cannot find because you got two. You got algorithm and bootstrapping. Both look like the same, but inside they got some few items that bootstrapping got, like p-value. Hello, this one don't have. So when the time I want to extract the data for p-value, wait, what happened? I don't know what I clicked already. You see, what technical problem? Oh, go back here again. When I want to get the data for p-value, I don't know where already lah. Then I accidentally open the PLS algorithm file, so I find already, then cannot get, right? Then so you have to see got two Excel file. So this one get from PLS algorithm, right? Got any message here? Then so HTMT if you use as a criterion should be lower than 0.8 or 0.9. Up to you lah. Maybe lower than 0.8, right? Or not so stringent requirement, you can lower than 0.9. So you see all these are lower than 0.9, except this one are lower than 0.8. Except this one also lower than 0.9. So consider as okay lah. Okay. So discriminant validity pass. Okay. Next is what? Quality. So you go back to here. Yeah. Internal consistency, okay. Convergent validity, okay. Discriminant validity, okay. So now collinearity. Collinearity same like your secondary data. You use VIF, variance inflation factor. Okay. So you calculate you also get back the result from calculate the PLS algorithm file. Here you see collinearity statistic VIF. Okay. We go back to the Excel file. It's still algorithm, right? You go back to navigation. Okay, file collinearity. I'll give another color lah. So, right? Then you click show. Usually will come at the last here lah. You have to scroll down the mouse, right? So all this one. Rule of thumb is less than 5. If you're not so stringent, right, that you are not so particular, okay lah, less than 10 also can, right? So for here, you notice that all are less than 5, right? So it's okay. That means these variables do not correlate with each other, right? Supposed to be independent variables do not correlate with each other. Okay, so because you see, your question A1, A2, A3, A5 are supposedly not related to B1. Let's say your question A2 are supposedly not related to other question. If your question A2 are strongly related to question B4, that means these two are the same. Sometimes we construct question, sometimes also when I answer the survey question, you notice that, I thought this question I have answered like about the same like the previous few questions before. So in this case, I might just click back the same answer, right? So like in this case, you'll notice that why your A2 and B4 seem like same answer. So in this case, mean they have coronerity, right? But of course, if some very, very professional survey questions, primary data, they purposely do a question that's same so that can test the consistency so that the respondent will not chincai lah, just put all 3 3 3 3 or chincai tembak lah 1 2 3 4 6 7 1 2 5 6 7 7 9. They won't see the question. Then supposingly they just purposely make one question and the other question is the same, right? You put one, another put 6, then they mean show this one just cincai tembak one, so tak boleh pakai, so you cancel out. Okay? Yeah. But of course, we won't do like that. So in this case, you see, we are at rule of thumb. If you do not do such thing, right, you just use the question, ask them to do, then this one supposed to be less than 5, okay? Or less than 10, sometimes is acceptable. Okay? Also good. Until here, okay? Okay? So you cover here. Any question? Yeah. Okay. We do check all these things already. Then next is the path modeling. Or if you want to equate it with the secondary data, is you see the coefficient, the relationship, right? The relationship we call path modeling. Before that, we check the quality criteria. Quality criteria is just the R square. Same like if you do the secondary data, R square in this case is 0.478. 0.478 mean all your factor A and factor B and all everything can explain 47.8% of factor Y. So in this case, there may be another 50 something percent is not explained, right? Adjusted R square is like you adjusted already for the number of variables. So usually it's the same lah, right? So depend on something. If you're exploring data, you may need less, right? Even though you do panel data, if you do you are not do forecasting, then you can accept to be lesser, right? So this one is just how many your factor A and factor B can explain how many percent of Y. So in this case, 47.8%. Okay. Okay. Next, we do the structural model. Okay, we see here. If you see back the diagram, it's about like that. Because this one is I run and copy and save some time ago. So if you run again, it may be different slightly. Okay, see. This one is your cross-loading. This one is a significant value. Same like your factor A to factor B. 0.184 is your beta. Right? Sometimes they call beta. Sometimes they call path coefficient. So just a name only lah. Here we put back beta so that you can for those who used to do secondary data, it's easy to understand. For sometimes you see the journal or they also put path coefficient. Beta is also a coefficient lah, right? So what is the path? Okay, wait you will get result from like that. But you cannot cut and paste the table, even though for just now the discriminant validity, internal validity, all these things. Also, you cannot cut and paste like that. You have to arrange in the table format, right? How you arrange in the table format? You go and download some of the journal paper, then you know, right? So factor A to factor Y, factor A to factor Y. The beta is 0.1148, right? The T statistic is 0.258. The p value is 0.04. So the p value is 0.033 here. In this case, they round out to 0.4. This one is because maybe I run it and save this one is in different time lah, right? That's why you see a little bit different, right? So factor B to factor Y is 0.54, right? So 0.546. So p value is inside the bracket. So both are significant at 5%, right? In fact, this one is significant at 1%. So therefore, factor A and factor B are valid effect on Y. Okay, then how do you get this one? Path coefficient. Yeah, I didn't see this one. Oh, this one maybe I have to add a little bit here. You get this one, path coefficient, from bootstrapping. Okay, you get it from bootstrapping. So you remember, maybe later I add first and only I upload now. Okay, from bootstrapping. Maybe I add again. Wait. not diagram, result. Okay, so here, bootstrapping, right? Half coefficient. You see, click. As I say, usually you at the bottom one here. So, you see here, this one don't have. Why this one don't have the? Is this the one? Oh no, here. Sorry. Not this one, histogram, not this one. Don't color here. Half coefficient. Final result. Half coefficient. Okay. So you click here. Half coefficient. Nah, you get the same. You see, you get the same table. Okay. We see the original sample, the t statistic, and the p-value. Okay. This whole table is exactly the same as this one. Right. Some of you may want to present in a more detailed manner. You can also present the 2% confidence interval or something like that. 2%, 2.5%, and 97%. You can present the confidence interval, right? Or otherwise, the first table will be enough. Okay, this one. Okay, so far so good. Got any question? Okay, I repeat this one. You want to see the beta, that means you see, go back to the very first one. Very simple one. A to Y, B to Y, right? A relationship to Y, we call the number is we call beta. Same like your secondary data, you got Y equal to x1 beta 1 plus beta 1 x1 plus beta 2 x2 x1 and x2. So the coefficient or the beta is the beta. So in this case, A to Y, x1 to Y for your secondary data is a beta 1. X2 to Y is beta 2. So A1 to Y is also beta A, B to Y is also beta B, right? So this relationship, the number is captured as here. Yeah, too small, you can see. 0.184 and 0.546. And the significant p-value are inside the bracket, right? Or in the table form here. Okay? As I mentioned to you, if you copy the diagram first, and then later on, you forgot to download the sample or you forgot to copy the diagram, you rerun again, they may be a slightly different, but still won't make any significant because still significant at 5%. Okay? Cool. But you present the data nicely in the table form. Okay? So something like that. Any questions so far?